So inverse trig functions are a little different because you're working backwards. So for instance, usually how they ask you for the cosine of pi over 3 and you'll give the cosine value. For inverse trig functions, if I ask for the inverse cosine of 1/2, that means I'm giving you the cosine value, you're going to tell me the angle. So it's working in the opposite way. So one of the things to note is that arcsine and arctangent is only restricted to quadrants 1 and 4, whereas arccosine is restricted to quadrants 1 and 2, and that comes from the graph. So for instance, if I were to ask you the arccosine of 1/2, meaning where does cosine equal to 1/2, there's two places. There's one here and also one in quadrant 4. So to restrict that so that I only have one quadrant where all the cosine values are positive and only one quadrant where all the cosine values are negative, they're restricted to two quadrants each. So just make a note of which quadrants they are. I will label the quadrants here as well. And then I just provided a cosine graph above just to show you that this is where it stems from. So from 0 to pi, notice that the maximum all the way to the values to the minimum are covered. So after that, all the values just repeat. So I only need the values from 0 to pi to just have all the cosine values. After that, everything repeats. So from 0 to pi is quadrant 1 and 2. But you don't have to know the proof. I'm just kind of explaining that. One of the examples we could look at is the arc sine of negative 1/2. So if you look, sine is negative, not in quadrant 1, but in quadrant 4. So arcsine is restricted to quadrant 1 and 4. In 1, it's positive. So I'm going to look in quadrant 4 for an angle where sine is negative 1/2. Remember, sine is the y value. It would be here at 11 pi over 6. So usually you want to answer the values in radians. Another way to say 11 pi over 6 is negative pi over 6, because the negative just means that you're going clockwise, you're going in this direction, and the pi over 6 tells you the distance you're going. So remember, pi over 6 is 30 degrees, so I'm going a distance this way of 30 degrees. So I'm going downwards pi over 6, which 11 pi over 6 and negative pi over 6 are the same angle. They're coterminal angles. So just note in quadrant 4, you can write the angles that way. This would be negative pi over 4. This would be negative pi over 3. So if you see it that way, just know that they all mean the same thing. For arctangent of 1, well, first of all, I'm going to look at inverse tan and note that it's also restricted to quadrant 1 and 4. So I'm restricted from here to here. From quadrant 1 to quadrant 4. So for tangent, where does the tangent value equal to 1? Remember, tangent is the angle that's by its, or the value that's by itself. And tangent is positive in the first quadrant. It would be 1 right here at pi over 4. And for the final one here, arc cosine of 1/2. Again, arc cosine is the only one restricted to quadrants 1 and 2. So I'm looking at quadrant 1 and 2. This 1/2 is positive. I'm going to go in quadrant 1, look for the x value where cosine is 1/2, and that would be at pi over 3. So you may see problems like this as well, and just make sure, for instance, in example 4, that you work inside of the parentheses first. So don't take the whole problem on as a whole. You're just going to work inside the parentheses first. It's the same thing we've been doing, the arc cosine of 0. So meaning I'm going to look for the angle where cosine is 0. Remember, inverse cosine is restricted to quadrant 1 and 2. So from here to here, where does cosine equal to 0? And that would be at pi over 2. So I'm going to change this parentheses value to pi over 2. I'm going to bring down the sign. I haven't used it all. And my new problem is the sine of pi over 2. Well, what is the sine value at pi over 2? It's 1. So you may have problems like this where you're working both of them. Just make sure you work inside the parentheses first and just kind of follow through from there. Now, if you look at number 5, this is a value that is not on the unit circle. So arc sine of 3 over 5. 3 over 5 is not on the unit circle, not for sine, not for cosine, not for tangent. So if this ever happens, you want to go back to SOHCAHTOA, meaning they're going to give you a right triangle and they're telling you the sides for sine, which is 3 over 5. Remember SOHCAHTOA, sine is opposite over hypotenuse. Since I'm given sine, the 3 and the 5 are the opposite and the hypotenuse values. So if I were to put the angle here, the side opposite of that is 3, the hypotenuse is 5. To solve for the third side of a right triangle, I would use Pythagorean Theorem, a squared plus b squared equals c squared. So 3 squared plus b squared equals 5 squared. Doing your algebra, since I'm out of room here, b would equal to 4. Even if you square root 16, it would only be positive 4, not positive and negative, because remember, this represents a length, which can only be positive. So now that I have all three sides of the right triangle, I can work outside of my parentheses now, and they're asking for the tangent value of it. Using SOHCAHTOA again, tangent equals opposite over adjacent. So the opposite side is 3, and the adjacent side, which is the side the angle sits on, is 4.